In this video, we're going to talk about trigonometric angles. In trigonometry, we have plenty of formulas to consider. One of them are addition and subtraction formulas. Now, let alpha and beta be angles in a unit circle. The first formula, we have sine of alpha plus beta, that is just equal to sine alpha cosine beta plus cosine alpha times sine beta. Second equation or formula, we have sine of alpha minus beta, same appearance. The only difference is we've just turned the operation from addition to subtraction. The third formula, we have cosine of alpha plus beta. Here, we have cosine of alpha times cosine beta minus sine alpha times sine beta. Number 4, cosine of alpha minus beta. We have cosine of alpha times cosine beta plus sine alpha times sine beta. The fifth formula, tangent of alpha plus beta equals tangent of alpha plus tangent beta all over 1 minus the product of tangent alpha and tangent beta. And lastly, we have tangent of alpha minus beta, that is equal to tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta. We're going to prove only formula number 4 and the rest will left as an exercise. In order to prove formula number 4, first let us consider a unit circle. In a unit circle, we all know that its radius is 1 unit. Therefore, we can say that P or this coordinate is 1, 0. So we have 1 unit on our abscissa and 0 units on our ordinate. And let us consider a terminal ray on this part. The question is, what is the coordinate of this point? Now, if we treat the angle generated as alpha, the coordinate of this point is cosine alpha, sine alpha. Remember, cosine represents our x or the abscissa, and sine function represents y or the ordinate. And we will call this as point A. Another angle or another terminal ray on this location, so let us consider this as angle beta. The coordinate of this point is cosine beta, sine beta, and we will treat this as point B. Now, the angle generated between this terminal ray and this terminal ray is angle alpha minus beta. Now, by connecting points A and B, we will form an equilateral triangle. Now, let us consider another unit circle. Obviously, this is the origin and your 1, 0. At this situation, we're going to consider a terminal ray on the standard position, which is on the positive side of x-axis, and another terminal ray on the first quadrant. And the angle generated between this ray and this ray is again angle alpha minus beta. Now, this point will treat as point C, and its coordinate now is cosine of alpha minus beta, sine alpha minus beta. Again, connecting points P and C, we will obtain an equilateral triangle. Since equilateral triangle, all sides are equal, that means side AB must be equal to side CP. Again, since equilateral triangle, all sides are equal, that means side AB and side PC must be equal. Allow me to write that in terms of equation. We have AB equals CP. But what is AB? Let us get AB first. AB came from the left unit circle. To find the distance of side AB, we have to use distance formula. We all know distance formula is d squared equals x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. And we let the coordinates as x sub 1, y sub 1, x sub 2, y sub 2. Substituting, we have ab squared equals cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. Expanding, we have cosine squared alpha minus 2 cosine alpha times cosine beta plus cosine squared beta. You can verify that. And sine squared alpha minus 2 sine alpha times sine beta plus sine squared beta. Combining similar angles, we have cosine squared alpha plus sine squared alpha and cosine squared beta plus sine squared beta minus, let us factor out 2 on these terms, negative 2 rather. So we have minus 2 times quantity of cosine alpha times cosine beta plus sine alpha times sine beta. We all know in trigonometric identity that this is equal to 1. This is also equal to 1. So we have 1 plus 1, which is 2, minus 2 times quantity cosine alpha times cosine beta plus sine alpha times sine beta. We will call this as equation single star. Now let's go to right unit circle. On the right unit circle, we have PC. So on PC, using distance formula, PC squared equals cosine of alpha minus beta minus 1 squared plus sine of alpha minus beta minus 0 squared. So if we will treat this as x sub 2, this will your y sub 2, this will be your y sub 2 rather, x sub 1 and y sub 1, you will obtain this. Now simplifying, we have cosine squared of alpha minus beta minus 2 cosine of alpha minus beta plus 1 for this term. And for this term, we have sine squared of alpha minus beta. Combining similar angles, we will obtain cosine squared of alpha minus beta plus sine squared of alpha minus beta minus 2 cosine of alpha minus beta plus 1. We all know from trigonometric identity that this expression is equal to 1, right? 1 plus 1, 2. Then, ikabit natin yung negative 2 cosine of alpha minus beta. We will have 2 minus 2 cosine of alpha minus beta. And tatawagin natin siyang equation double star. Now, sabi natin kanina, side AB and side PC must be equal. If we obtained AB squared and CP or PC squared, AB and CP must be equal since they are sides of equilateral triangle. Now extracting both sides, we will have AB is equal to CP, right? Or equating single star and double star, we will have 2 minus 2 cosine alpha minus beta equal 2 minus 2 of cosine alpha times cosine beta plus sine alpha times sine beta. 2 on the left part and 2 on the right part will cancel. And negative 2, divide ka ng negative 2 both sides. Negative 2 will cancel. And that will give us cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha times sine beta. And that is our formula number 4 under addition and subtraction formulas. Now let's talk about double angle formulas. If we let alpha is equal to beta or beta be alpha, and if we use the addition and subtraction formulas, we will have these three trigonometric functions. Under sine, we have sine alpha plus alpha. So, that is sine alpha times cosine alpha plus cosine alpha times sine alpha. Sine alpha plus alpha is sine 2 alpha. Since these are similar terms, we can perform addition. So, that will be now 2 sine alpha cosine alpha. Next is for cosine. For cosine, we have cosine alpha times cosine alpha minus sine alpha times sine alpha. And that will be cosine 2 alpha. Cosine alpha times cosine alpha is cosine squared alpha. While sine alpha times sine alpha is sine squared alpha. Okay. In trigonometric identities, cosine squared alpha is 1 minus sine squared alpha. We can substitute cosine squared alpha by this value. We will obtain 1 minus sine squared alpha minus sine squared alpha. Like terms, combine, we have 1 minus 2 sine squared alpha. Next, similarly, sine squared alpha from trigonometric identity, that is 1 minus cosine squared alpha. Substitute sine squared alpha on this equation. We have cosine squared alpha minus quantity 1 minus cosine squared alpha. Similar terms, combine, we have 2 cosine squared alpha minus 1. For tangent, tangent alpha plus alpha, we have tangent alpha plus tangent alpha all over 1 minus tangent alpha times tangent alpha. Tangent 2 alpha, on numerator, we have 2 tangent alpha, while on the denominator, 1 minus tangent squared alpha. Now, let us summarize the double angle formulas. Let theta be an angle in a unit circle. For formula number 7, sine 2 theta is 2 sine theta cosine theta, while cosine 2 theta is just cosine squared theta minus sine squared theta. Formula number 9, the alternative form of cosine 2 theta is 1 minus 2 sine squared theta. Number 10, another alternative form of cosine 2 theta is 2 cosine squared theta minus 1. And lastly, for tangent 2 theta, we have 2 tan theta over 1 minus tangent squared theta. Pangit pakinggan ng 2 tan theta. Now, from formula number 9, it may be solved for sine 2 theta as follows. This is formula number 9, ha? So, cosine 2 theta equals 1 minus 2 sine squared theta. Now, simply transpose negative 2 sine squared theta to left side and cosine 2 theta to right side. We have this equation and divide to both sides. This will cancel. So, we will obtain sine squared theta equals 1 minus cosine 2 theta all over 2. And we will call this as equation number 12. From formula 10, this is your formula 10. Cosine 2 theta equals 2 cosine squared theta minus 1. Right? Now, transform this using algebra and divide to both sides. Same procedure, just like we did on equation 12. We will obtain 1 plus cosine 2 theta all over 2 for cosine squared theta, and we will call this equation number 13. Now we have sine squared theta and cosine squared theta. What we are missing now is for tangent squared theta. To obtain that, replacing tangent squared theta into sine squared theta over cosine squared theta, we have 1 minus cosine 2 theta over 2, since this is your sine squared from equation 12. Then for cosine squared theta, that will be your equation 13. So 1 plus cosine 2 theta all over 2. Okay. Now, by simplifying, 2 will cancel. So we have 1 minus cosine 2 theta all over 1 plus cosine 2 theta. And therefore, tangent squared theta equals 1 minus cosine 2 theta all over 1 plus cosine 2 theta. And this will be our equation number 14. Ngayon, di-display lang natin yung na-generate natin equations 12, 13, and 14 dahil may gagawin tayo. From these formulas, getting the half of an angle, we have theta is equal to phi over 2. So, yung mga theta na nakikita natin sa equations 12, 13, and 14, hahatiin natin. And we will replace it as phi over 2. Now, sine squared theta on equation 12, let us replace theta as phi over 2. We have sine squared of phi over 2 equals 1 minus cosine 2 times phi over 2 all over 2. 2 and 2 will cancel. So that will be 1 minus cosine phi all over 2. Solving for sine phi over 2, extract the roots. We have sine phi over 2 equals positive or negative square root of 1 minus cosine phi over 2. And this is the formula for your half angle under sine function. For cosine function, cosine squared theta, substitute phi over 2 into theta. Same procedure, just like what we did. We will obtain cosine squared phi over 2 equals 1 plus cosine phi over 2. Extracting the roots both sides to obtain cosine phi over 2, we have positive or negative square root of 1 plus cosine phi over 2. Ang kaibahan lang from sine functions that minus yung operation, while for cosine, addition. And lastly, we have tangent squared phi, and that is 1 minus cosine 2 times phi over 2. Nakuha to under equation number 14. Then for its denominator, we have 1 plus cosine 2 times phi over 2. Then cancel yung 2 natin. Makakakuha po tayo ng 1 minus cosine phi all over 1 plus cosine phi. Extracting the roots, we have tangent phi plus or minus square root of 1 minus cosine phi all over 1 plus cosine phi. And that is it. So, as a summary, half angle formulas. Let theta be an angle in a unit circle. Formula number 15, we have sine phi over 2 equals plus or minus square root of 1 minus cosine phi over 2. Then, formula number 16 is for cosine phi over 2. Same appearance. The only difference is that we use addition sign instead of subtraction. And for number 17, our last formula, tangent phi over 2 is equal to plus or minus square root of 1 minus cosine phi all over 1 plus cosine phi. Thank you for listening, and I hope you learned a lot from this video. See you guys, and God bless.